Hi folks, in this short tutorial I'm going to tell you how we made the BuzzWire game using Arduino Uno. It is a very simple code to accomplish a very interesting task. So those of you who are new to Arduino programming can also get it very easily. It's a very simple program and a very simple circuit. So for those of you who haven't seen an Arduino board before, this is what an Arduino Uno looks like. So you have the microcontroller chip out here, and you have the pins out here which are labeled from 0 to 13, and then ground and a reference pin, and there are also pins out here. There is a USB plug. This USB plug is used to connect the Arduino to your computer or PC. So this is also used as a power port. So what happens when you connect it to the computer, it not only sends data to and from Arduino, it also sends power. So you don't need external power supply for your Arduino board. In case you need an external power supply, there is also a separate port. Like we used in our BuzzWire game, we used a 9-volt battery as an external power supply. The circuit we will be using in the game is out here. So you have a send pin that sends a signal through a resistor R, and there is a receive pin which receives the signal. And this is our wire out here. So when someone touches the wire, what happens? He adds an extra capacitance to the circuit, and this receive pin senses this change in capacitance and does the work what we want it to do. So these send and receive pins are exactly the pins which we found out a little earlier out here. So these are all the pins which we can use as send and receive pins. When we explore the code, we will come to know that which two pins are used for sending and receiving in our program. Now what we'll do is we will connect our Arduino board to our computer using a USB connector, and then we will open Arduino IDE. So Arduino IDE is Integrated Development Environment for Arduino. What it essentially is, it's just a program where we can thus write it's just a software where you can write programs for Arduino and feed those programs from this software to your board directly. So this is what a main window looks like. So this is what the software looks like, and you have two functions out there in the sketch. So Arduino programs are referred to as sketches, and you have two functions already present in there, that is void setup and void loop. So what will void setup do? That when we'll execute the program in our Arduino Uno board, this setup will execute once. Once it is executed, then we'll go to loop. So what does loop does? All the statements which we have mentioned inside the loop, they will continuously execute till infinite time in loops. So we can write a code that repeats itself again and again. So okay, so let's begin the program. So the very first line of the code is include capacitive sensor dot h. So what is this? Capacitive sensor is a library within Arduino that is used to handle all the operations concerning sensing of capacitance. So what we are doing with this statement is that we are including that library within our program. Now let's go on to the second step. We'll create we'll go inside the setup, and we'll create an object of this capacitive sensor class so that we can use the functions from these class. So we have capacitive sensor, the object name, let's call the object CS, capacitive sensor, and let's pass 4 and 2 as arguments. What these 4 and 2 are: 4 is our send pin and 2 is our receive pin. This is how we assign pins. So these are two pins which we are using for sending signal and receiving signal. You can use other pins also, and that's completely up to you. We also define two variables of type long. One is long RD and the other one is maximum. Set maximum equals to 0. You'll come to know later when we write the program that why do we need these variables. Now whenever in the game someone touches the wire, you need to have a response from the board itself. Let's say you want some buzzer to make some sound, or you want an LED to glow. So for that thing you need one more statement in this program, that is pin mode 10 output. So what this statement does is it assigns a role to pin number 10 on our board, and that role is that it shows the output. You can try it with various other pins also, like 11, 12, but not these two pins. So this is our setup. There's one more statement which I want to write out here, is cs.set underscore cs underscore autocal underscore millis, and you write 0x f f f f f f f 8 times. So what this statement means, cs, as we know, is the object which we have created from capacitive sensor class, and set underscore cs underscore autocal underscore millis is a function within this class that controls the calibration of Arduino. So what Arduino does, that after a certain interval of time, by default it's 20 seconds, so after every 20 seconds it sort of recalibrates what zero signal means for itself. So if there is some capacitance out there, it will decide that okay, this is 0, and what over and above is what I have to detect. So what 0xFFFFF 8 times does, it turns this recalibration off. So what we'll do now, we'll just calibrate our Arduino once, and that calibration will carry on for the rest of our game, so that it doesn't create a problem for us. You can experiment with this and discover out what it means if we change this or if we don't use this statement. Next we define a for loop. It's for int I equals 0, I is less than 100, I plus plus. Inside this loop we use the variable RD which we have defined earlier, and we use one more function from capacitive sensor library, that is cs dot capacitive sensor. Let's pass 16 there. So what this does, this particular function does, that it senses the value of the capacitance, and it returns a long number corresponding to that capacitance. Mind you, it doesn't return you the exact value of the capacitance, it just returns a number which signifies how large your capacitance is. So if you have more capacitance, the number returned is larger, and this 60 out here is the resolution of the reading which it returns. You can play around with this and figure out what works for you. So before going any further, I would like to show you what kind. So here is our Arduino board returning values, as you can see, and as I'll touch it, you'll see a drastic change in these values. So as I touch it, you see it's 13,000, 10,000, stuff like that. So when I touch it again, you see 64,000 comes in. I touch it again 16,000 comes in. So normally it's a low value, but as soon as I touch it, the value goes high, and this is what we sense. So now the problem is, how do we decide what is the value which we have to take for a sensed signal and an unsensed signal, so that we can differentiate between the two? And this is what this for loop is for. So we run this loop 100 times, it reads the value, and we calculate the maximum value by this condition, so that if RD is greater than max, then maximum is equals to RD. So at the end of this loop, what happens, we have maximum value of capacitance out here. Let me remind you, what we are storing in max out here is the maximum value when we are not touching the wire. So now when we go on to this loop, to the function, not this for int loop, to the function itself loop, we are going to check that if the value of the number returned is greater than max, then there is someone who is touching the wire. So how do we do that? We again assign rd is equals to cs dot capacitive sense. We again set the resolution to 60, and we say if our rd is greater than max plus 50, let's say, why we then we want our buzzer to go high. So as you remember that we have put we have used pin 10 as our output, so we'll do digital write 10 high. So what happens whenever someone touches the wire, so the number returned is higher than max, it enters this if condition and pin 10 goes high. So we can put up an LED or a buzzer on pin 10 that will tell us whether someone has whether someone has touched the wire or not. There can be a question out here that why do we use this 50? So there has to be a noise margin. So as you saw the numbers were random, so there can be noises in the system. So we sort of, to buffer that thing, we have maximum plus 50. So if rd is greater than maximum plus 50, it's more of a better thing to do. You can play around with this number, you can use 50 or any other number and see what works out for you. Now, but there is a slight problem in this code. What happens that if someone touches the wire, pin 10 goes high and it remains high forever. So what we'll do, we'll add a delay of 1000 milliseconds, that is 1 second, and we switch off our buzzer or LED which we are using. So pin 10 now goes low. So what happens when somebody touches the wire, pin 10 goes high for 1 second and then it again goes low. So as soon as someone touches the wire, the buzzer goes high, rings for a second and then stops. So yeah, this is all the code which we need for making this game. I mean, this is as simple as this. So what you do now, verify it. They'll ask you to save a code. Let's say write BuzzWires. So after saving your code, you click on this tick mark, which is to verify your code. Okay, now comes the error message. There's a syntax error out here. I think the L out here is in capital. Let's verify it once again. Okay, this is also an error. The C here is small. So it's a very handy tool to verify your program before finally compiling it and sending it to your board. So it says RD wasn't declared in the scope. So what you can do is cut RD from here and paste it outside. So you can define your variables out there also. Save the program, verify it again, and what it says, CS was not declared, so I think you have to declare this thing also outside the program. So this is also a hands-on session on how you fix bugs in your program. Let's verify it again, compiling sketch, and hopefully I think we get it this time. Yeah, done compiling. Oh, lucky people. Now what we'll do, we'll click the button upload, and there's a problem uploading, so that happens quite frequently with Arduino. Sometimes it doesn't detect it. Go to the port, select Arduino, now try uploading it. Yeah, it's uploaded, it's done uploading. So this is pretty much how you make a BuzzWire game, and hope you would try it. If there are any comments or suggestions or questions, you're free to ask. Thank you, signing off. Hope you enjoyed the video.